Hello everyone, this is the second part of this tutorial series. In this video, we will be discussing about the client-side prediction algorithms. And first, we will discuss about the need of this algorithm. So, in the previous video, we discussed about that the client is sending the input to the server, and server is processing the input and then sending back the output to the client. Then the client is using that output to move his characters. So, in this process, there can be some delay or input lag can you can call it. So this will be very inconvenient for our players. So what we will do is that this algorithm will help in preventing this, or like make illusion for the player that he is actually moving the character in his own game, not the server is doing something. So now we'll be discussing about the algorithm. So suppose this is your client side and this is your server side. So how will the algorithm start is that every frame you will capture the input or the keyboard state or mouse state, whatever the input is pressed by the user. Then you will process the input on your client side. So then the user will see the character moving in real time. Then you will save the output and input in an array. So in this array you will save the input. uh, in this array you will save the input, and in this array you will save the output. Okay. Then you will send the input to server. So then the input will be sent to server. So then what will server do is, when the input is received, then server will process the input and send the input output back to client. So as you can see here, we are sending the input to server. So what will be the input packet format? So input packet will contain two details: the frame numbers and input data. So if there are many clients, then it will also contain the client number. So for now we have only one client, so it will contain frame number and input data, the frame number, which frame it is processing. Okay. So now a client has sent the input packet to the server, and then server processes the input and send back the data to client. So now what will the output packet will look like? The output packet will look like this. So it will contain the frame number, which input was processed, and the output state after processing this input. So now after this, the control will come back to client side. The packet, when the packet received on the client side, this reconciliation function will be called. So what will this reconciliation function will do is that if it will check if the output matches our output. So like what it will check if the output state described in this output packet is matching the output state which we saved here. So it will verify if the client is actually moving the amount or actually changing the state as expected by the server. So now if the output doesn't matches, then all of the input which are stored here will be reprocessed till the current input, which is all of the input which are stored here will be reprocessed, and all this output will be filled again. So now I will take example and show you by trying the algorithm. So suppose now here is our client side. So it is client side. Please bear with my handwriting. And this is the server side. Okay. So now this is our input array. So now currently our input array is empty, and this is our output array. So our output array is also empty. Okay. So now suppose we have a character here uh, whose velocity is 1. And for now, if the user is now the frames are starting, the physics frames have started, or in which any frame you are processing the input. So now frame is starting, and the first input was input for frame 1 was the user presses the forward button. So let me write it more clearly. So for this was the first frame. So it was a first frame, and the input was forward button. Okay. So now you process this input. So this will be stored here. So here is the frame is one input will be stored here. Now you process it locally on your client side. So the output will be like that. So this is the input frame, and then the output will be, you process it, then output will look like this. For frame is equal to 1, output will be, the position is now x is equal to 1. It is starting from x is equal to 0 because the velocity is 1, so the position is 1. Okay, so now this will be stored in this here we'll be storing this. Here it is, frame 1. Wait, let me write it more clearly. So the new position will be, after this output, the new position will be x is equal to 1, and you will be storing this frame here. Okay, so now you will also sending this input to the server. The server received this input, so suppose then it will process it here in his side. uh, this input is received, frame is equal to 1 and input is whatever, then it will process, then it will also conclude that the position is x is equal to 1. Suppose for now it is still processing the input, and then again the again the another frame passes on the client side. So again this is frame number 2. So in this frame the user is not pressing any input, so there is he is not pressing input. So now after the processing of this input, the output will be, frame is equal to 2, output will be x is equal to 1. Okay, so now you will be saving this input also. So here f is equal to 2 is stored, and here 2 output for the 2 is stored. So input will be stored here, and output will be stored here. Now now this we have received this packet from server, this output packet. So output packet is like this. It will be showing f is equal to 1 and x is equal to 1, because it is for the output packet for the frame 1. So now as we can see, after receiving we'll be noting the frame number which is mentioned in the packet. Then we'll be searching this frame number in our input array, and when we find the input array, and then we will be searching this frame number in the output array also, then we will be matching this output also, both. So suppose this is output from the server, and this will be the output from local. Then our local output will be trying to match it with output from the server. Okay, and if this doesn't, uh, for now we can see it is equal. So in next example find we'll be discussing about which is will not, if it is not equal. So now this are equal, so this input you can delete this input now. So similarly this packet will also be sent somewhere in that algorithm. So now this how the algorithm will go on. Now we will discuss the example number 2. So if you guys didn't understand anything in the first example, you will get this in the second example. So this is your client side and this is your server side. So here the starting position from in client side is x is equal to 0 and y is equal to 0, and x velocity is 1 and y velocity is also 1. So same is on the server side, x starting position is x is equal to 0, y is equal to 0, and velocity x and velocity y is 1 both. Okay, so now there are three input options given to the user. So first input option is forward x, it is denoted by this sign, and and second is forward y, this is denoted by this sign, and second is this no input, it is denoted by this sign. So now what will happen is, suppose for the first frame, now the first frame input, the user is pressing this forward input, and this is frame is equal to 1, and we will save this in the input array. And the output for this frame, output for this frame will be it is the user pressing in x direction, so the velocity of x is equal to 1 will be used, and the output will be x is equal to 1. And wait, let me create it more clearly. So output will be x is equal to 1 and y is equal to 0. So this is for frame for 1, and this frame will also be sent to the user, sorry, not user, no, to the server. So server will process this frame. So this frame has arrived to the server. So we'll discuss this part later from the server processing side later. So now for the second frame, the user is pressing and is not pressing any button, and so the output will be same. The output state will not change, so it will remain x equal to 1, y is equal to 0. And for the third frame, the user is pressing the upward button, this forward y button. So what the output will change to uh, frame. This is frame 2, and this is 3 is equal to 1. So now suppose the user want to cheat. So now he has changed the this y velocity y to uh, it is changed. He changed it to 2. So now on the input on the client side, this will be y is equal to 2 because the previous output state was 0, and then the forward button is the forward y button is pressed, so the it is changed to y is equal to 2. So now this frame, these two frames will also send to the server. So here it is frame 2, which is it doesn't have an input, and this is frame 3. Uh, it has a forward y input. Okay. So now what will the output of this frame? Now we are discussing about the what will be happening on the client server side. So output of this frame will be uh, x is equal to 1 and y is equal to 0 because the forward button is pressed and velocity of x is 1. So the output state will be changed to x equal to 1, y is equal to 0. Then the output will be the output of this frame will be sent to client. So now client received this output, and now this will be compared with the frame output of the frame number 1. So this is the output of frame number 1. As you can see, these are equal, so this frame is valid. So now we can remove this frame from our array. So this frame will be removed because this output is because you can see this output x equal to 1, y is equal to 0 is matching with x equal to 1, y is equal to 0 on the server side. Now we'll be removing this frame. So this frame we'll remove. This frame is passed. So this frame is verified. So now uh, let's discuss about this frame is equal to 2. So now the frame is equal to 2. For the output for this frame 2 will be uh, it will be it will remain as x will remain same and y will also remain same because no input is pressed, and so it will be also moved to the client side. So this will also be compared, and you can see the output of this frame 2 is x equal to 1 and y is equal to 0. It is also x equal to 1 and y is equal to 0 on the server side also. So this frame is also passed. Okay, so now let's talk about the third frame. So in third frame, you can see the output in the on the client side is x equal to 1 and y is equal to 2. And what will be the output on server side? It will be x is equal to 1 and y is equal to not 2, it will be 1. So because the velocity y velocity is 1 on the server side. So now when this frame will be sent to client, the algorithm will compare the output position of the two from the server side and the client side. So it will compare that to see that x is equal to 1 and here is also x equal to 1, it is valid. Then y is equal to 2 and y is equal to 1. So there is some it is not equal. So there is something suspicious going on. So now what this algorithm will do, that it will believe the output from the server side, and it will forcefully set the output of this frame to 1, and it will move back suppose the server is now the client character is now at x equal to 1, y is equal to 2. It will move back uh, it will move back to x equal to 1 and y is equal to 1, and it will forcefully reset the server the client character. So now what will happen after that? So suppose when till the time when this frame 3 is reached the client, lot of other frames are passed. on the client side also. Suppose this frame is equal to 4 is has went on, and then frame is equal to 5, then is this all frames the output is also stored. Then this all output will be invalidated, this all output will be deleted. Then here output will be set to 1, and this all output will be calculated again using this the input frame stored. So let's now move to the code, and let me show you how I implemented this algorithm. So this is the client side of the code, and this physics process function will be called every time the physics frame is called. So in this physics process function, I am taking this storing the input in this input dictionary. This is a dictionary type variable name input, and this will be relative to your coding language, whatever you are using. And now I am using Godot, so I have written the code in this Godot editor. So here in this I am storing the input in the input variable, and basically I am storing the state of the current input. So this is for front movement, back movement, left movement, right movement, and this is for jump, and this is for shoot. I will discuss about the shooting in next some lectures. So here I am processing the input in this process input function. So as you can see, I have passed the input variable here. So let me show you the process input function. So this is the definition of the process input function. This is a long function. This handle all the movement of my game. So this is all the process process input function. At last, I am storing the result state. What will be the result state? So you can see the body global position is and global rotation, head node global rotation is stored in this result state variable. Then I am returning this result state variable from this process input function. So now let's again go to the phys process function. So here I have shown you the process input function, and the output from the process input function will be the result state, which will be stored in this variable name output state. So now here I am creating an input packet. So in this, the input packet is a dictionary. Basically, it will have a variable called f, capital F, which will have the physics frame count, which is the number of the physics frame, which is currently going on, and it will also have a variable capital T, which is the current time, and if in the uh, input variable, it will store this the input. So dictionary has an input key which will where the input state will be stored, which I generated here. And also let's ignore this if statement. This is for the testing part. So here I am creating the output state. You can ignore this if so. Don't you, you can comment also. So, but now I will not comment it, but because it might break something. So in the output state information, I am storing the physics frame of the output of the input packet. So this is you can see this is the same physics frame variable. This and this variable are same, and here and in the time I am say storing the same time as the input packet, and in the output state I am storing the output state which was uh, thrown which were returned by this process input function, and I am storing this output state info to the output state info array. And also you should notice that I am storing the input packet to the input array, and also sending this the input packet to the server. So now let's move to the server side code. So uh, this is the server side of the code. So this whenever the input packet is received, this process input function will be called on the server side, which will extract the input from the input packet. So now this is the input, and it will process all the input. So this is all the input is being processed, and it will also generate a result state, and it will now also create an output packet. So output packet will have the time same as the input packet, and the frame number will also be same as the input frame, and the result state will be stored in this result key, and this will be again returned back to the client using this function. So now let's move to the client code. So again, This is the client code. So when the server is returning the output packet, so now this reconcile function will be called. So this is the result packet. So we will extract the result here. This result state will be extracted from the result packet. So this result state is the output for the output of the server as after processing the input frame. So here result packet also has a F key, which is the frame number of the output input packet, which is processed for the and used in generating this result. So here I am removing all the input frames which were before the this output frames, output frame number, because this is basically no need of use because now we have the latest result frame arrived. So now so I am removing the input packets and the older input packet and output older output packets for those inputs. So now all the older input packets have removed, and I will also check if the current output the the output packet, the zeroth index, have the same frame number as the as the result packet. So now this validate state, now this will compare the uh, the result state which is arrived from the server and output state which was generated in on the client side, because as the frame number we checked here, the frame number is same, so otherwise it would have returned. So validate state, you can see here, it is basically checking the state on client. This will be a state on server, uh, because this validate state result state will be passed at the state of server, and output state info array will be passed at the state of client, as you can see here as the variable names. So now I am checking the difference of the vector bit of the state client position and server same client position on the server. So if this vector length is greater than 3, I have given the threshold of 3 as there might be some a little bit floating point error, so I am going with this 3 threshold. If the length is like difference vector length is greater than 3, then it will return false. The same is with the similar type of condition is with the rotational body rotational difference, and the similar type of condition with the head rotation. If this all condition are passed, then it will return true, means the both are same, and if any of the conditions fails, then it will return false. So suppose this is approx variable is because the approximate this should these two, the result state and output in state info array, the output state should be approximately equal, because there might be some, as I said, that there might be some floating point issue or maybe like that. So is if is approx is false, means they are not even approximately close. So then it will print that this packet is false. Then I am printing the result packet for debugging purposes and output state packet for also these all printing. So then I will force set state. So the result state which will be arrived from server will be forcefully set to the client, because because now the algorithm is suspecting that this client is cheating. So now this forced set state, I am setting the client state to this expected state which was arrived from server, and then now I am clearing all the output state array, because now the another output will be generated from starting from this input. So now yes, as we have seen that we are currently storing the input in the input array. Now all the input will be processed again, and the new fresh output will be stored in this output state array.
Different.